Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll be demonstrating the use of multi-sided Indexial machining on this machine fixture. If we open up our Coordinate System Manager, you'll see in this particular case we have several different home positions on the part itself, enabling for the multi-sided machining. Now let's first take a look at the first operation. The first operation that we have is a Facemill operation. If I were to open up the Facemill operation, you'll see we'll be working in Mach 1 position 1. If I show the geometry, you'll see the geometry is this top border over here. The tool in this particular case is a 120 millimeter Facemill, and the levels is starting with the upper level of 2, going down a total of 2 millimeters. And in the technology, we'll be doing one pass, as the tool is large enough to cover the entire face. If I were to run my simulation, you'll see that the tool will come down, run across the part, go back up, and do one more pass over. Now, in the next operation, I've also done a Facemill operation, the exact same as the previous one, except this time we're working on Mach 1, position 2. The tool will be the exact same tool, levels the exact same way. It's just a copy of the previous operation, but this time it's on position 2. Again, running the simulation, you'll see that this time the tool will come on the side and do the Facemill operation. Now, in order to do it on the rest of these sides over here, since this part is the exact same on all 4 those sides, I use the option of transform, and we did rotate on the 4th axis every 90 degrees. By doing this, I was actually able to do 4 operations from 1 operation. Running it through, you'll see we have the first side, second side, third side, and 4th side, all done in this one operation using the option of transform. Now, in the next operation, I also used a Facemill operation to machine this side using its home position. And just as in the previous operation, I also used the option of transform to do this on all 4 sides. Next, we went into a profile operation. In the profile operation, we were working on position 4. And if we take a look at the geometry was this edge over here to mill out this surface over here. The tool in this particular case was a 10 millimeter end mill, and the upper level was from this line over here going down a total of 15 millimeters. In our technology, we've used the option of rough and finish, leaving 0.5 millimeters for the finish cut itself. And in the link, we had a lead in and a lead out of a 5 millimeter radius. Taking a look at the simulation, the tool goes in, mills out that side, and finishes off. Now, in this operation, I also did the option of rotate. So what will happen here was, after it finishes this side, it'll switch to the other side and do it as well, milling out that surface there as well. Next, I like to machine out this pocket over here. So for that, we've gone back to position 1, as shown over here, and I use the option of pocket machining for this particular operation. Using position 1 as shown over here, my geometry is the boundary around the outside of the pocket itself, and the tool in this particular case was a 10 millimeter end mill. Levels starting from 0 going down to 15 millimeters, which is that floor over there. If I were to run my simulation, you'll see that the tool goes down and works inside that pocket, cleaning out that entire pocket over there. Now, before we go on, let me just point out this particular wall around this pocket over here is actually tapered. So to actually finish this operation, I did another profile operation. And in the profile operation, we use this geometry on top over here. And the tool in this particular case was a 12 millimeter tapered mill with the proper angle of that wall. Going into my levels, again, you can see we're going down from this line all the way to here. And if I go into my technology, we'll go into advanced, and we use the option of wall draft angle, extending the wall angle at 10 degrees, which is the actual measurement of the angle of that particular wall. And in the technology, you'll see that we're doing a finishing cut, stepping down every 3 millimeters. The links has a lead in and lead out of a 4 millimeter arc. And if we take a look at the simulation, you'll see the tool will go down, and you can see it's a tapered mill. And every single time it goes down, it just moves itself in order to get that 10 millimeter angle. As you can see, the lines are moving in at every single level of the part itself, giving us that taper finish we needed with this particular tool. Now, in my next operation, I've continued with the pocket operations, but this time in position 2, working on these pockets around the part. Again, since these pockets are exactly equal on all 4 sides, I again use the option of transform and rotate in order to do all of these pockets. The actual pocket operation is very similar to the very first pocket operation that I did over here. Just take a quick look at the simulation of the part. You'll see that the tool goes down, works in one pocket, goes to the next one, third one, and the fourth one. Now, in my next operation, I wanted to work on this radius over here as well as this radius over here. For that, I've again worked in Mac position 2 since I'm working from the side, but I've used the option of HSS. Just to give a quick look at the HSS, I've used the option of morph between 2 adjacent surfaces, choosing these faces over here and the edge surfaces being this top over here and the second one being this one over here. Tool being a 6 millimeter ball and mill. Let's just go a quick look at the simulation itself. You'll see that the tool is going down, working back and forth on that surface. And since again I've used the option of rotate in my transform, I've done this as over here as well as on the other side as shown over here on the part. Done on both sides using the option of transform. Next, I need to drill out these holes that are over here. And these holes are M8 by 125 tap holes. Now we have this on this side as well as all 4 sides and on the top as well. So what I've done on one side, the operations are similar on each one of those sides. Also, what I've done on one side over here has been rotated to the other sides as well. Let's just open up the operations to see what I've done. If I were to open up the first operation over here, you'll see that we've chosen my geometry as shown over here, these 3 holes. And I started off with a spot drill of 10 millimeters and 90 degree angle. Levels going down to 0, but having the 8.5 diameter of that particular tool going down to 0, leaving for a 0.5 millimeter chamfer on the part itself. Taking a quick look at the simulation, and let's take a look now in Solid Verify. You'll see the tool comes down, does a spot drill on that side, and as I said, since I did rotate, it'll work its way over to the next side and do the same on the rest of the holes of this part giving it the spot drill needed. The same was done in the next operation, but this time being on the Mach 1 position as shown over here for these 4 holes. Now, the next operation was the regular drilling operation. If we take a look at the operation itself, we have our geometry. Our tool was a 6.8 millimeter drill. And if I go into the levels, we're going with the cutter tip all the way down to the bottom of the hole itself. In this particular case, we're going to technology. We'll be using a drill cycle type of pecking as it goes up and down into the hole itself. Taking a quick look at the simulation, you'll see that the tool goes down, pecking its way into the hole, doing it on each and every one of those holes as well. Now the same was done in the next operation, this time being on Mach position 2. Opening up the operation, again you'll see I have the geometries as shown over here. Quick run of the simulation, you'll see that it does the holes on every single one of those sides. Since over here, again, I'm using the option of translate within transform, and you can see the chamfer is still left on the part. Now, the next operations, I've also used a drilling operation, but this time using the tap. Again, using the exact same geometry I used before. This time, the tool is a 8 millimeter by 125 tap. And if I go into my technology, you'll see I'll be using the cycle for tapping. Running my simulation, you'll see that the tool goes in every single one of those holes, and now that's finished. The last drilling operation, we have again the tap, except this time it's on the top of the part as shown over here in the simulation as well. Now, in our last 2 operations, we have to put the chamfer on this pocket over here in Mach 1, position 1, and we also have to put a chamfer on these pockets over here as well. So if we go into the first operation, you can see we'll be using Mach 1, position 1, and the geometry is this edge over here. The tool in this particular case was a chamfer drill of 12 millimeters with a 90-degree angle, and in the levels I've gone down to this line over here. In my technology, I've used the option of rest material chamfer, telling the tool to use the 1 millimeter diameter of the tool for the chamfer drill itself. Taking a look at the simulation of the part, you'll see that the tool goes down and puts the chamfer on the part exactly the way I want it. The same was done in our next operations, and in our next operation we also use the option of transform so that it can also do it on all 4 sides. Again, going down on the edge itself, doing it on all 4 sides of the part. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.